Hello team, this is the second video on irrigation water requirement. This is Munene Engineer. Welcome to Engineer Munene's channel. We are going direct to the first example where it's saying the table 1 shows crop water requirement for the maize crop irrigated by fallow irrigation in a scheme. The precipitation is negligible, and if the salinity of the irrigation water, that is the water you're applying, is around 1.5, this electrical conductivity of 1.5, and the leaching efficiency is 70%. So then we have 90% potential, yield potential, corresponding to around 2.5 electrical conductivity of the soil. That is the soil salinity as an extract tolerance of 2.5. So you are told to calculate the leaching requirement as a fraction of each month. Then net irrigation requirement. Then the leaching requirement as a depth in millimeters. 2.5. Salinity of the water is 1.5, I mean. Then salinity of the soil is around 2.5. Then the efficiency we can talk, the leaching efficiency is around 70%. That is the water you are applying, you are expecting it to carry around 70% or to be 70% efficient in carrying the saline water deep zones of the soil layers. So here are the formulas. So the leaching requirement is given by the salinity of the water over 5 times salinity of the soil minus salinity of the water, then times 1 over leaching efficiency. So we are given on the table, we were given the crop evapotranspiration. This is the amount of water that is needed by the crop just to grow, which is around 6 months. That's a long-term crop, a maize crop. For the January, it needs around 50 mm. For the February, around 101, and all the way up to the maturity. Then so that we can calculate the leaching requirement, that is as a fraction. We have said for the first question is as a fraction of each month, as a fraction, like we are trying to calculate the leaching requirement for every month, of which is given by that formula. So we will be having 1.5 over 5 times 2.5 minus 1.5 again, then multiplied by 1 over the leaching efficiency. So for the first one will be around 0.195. Then since nothing is changing in the formula, the leaching requirement for all the months will be the same. Then we will need to calculate the second part, which is the net irrigation requirement. Net irrigation requirement is given by you can calculate in terms of the net irrigation requirement, or use the crop water requirement, or the crop evapotranspiration. So is given by crop water requirement over 1 minus the leaching requirement. So For the first one is giving you around 62.72. The second one, the higher the ETC, the more the net irrigation requirement. Net irrigation requirement is the crop water requirement for the growth plus the leaching water requirement that you need, because we have calculated for the leaching factor, that is the leaching fraction. It's enabling you to calculate the net irrigation requirement, so that now when maybe you want to find the leaching requirement for the water that you need for the leaching alone, you can just deduct. So for the second one, you can just check it that it's 1 multiplied by divided by 1 minus 0.195 and so on. Then for the leaching requirement, you just need to deduct, that is the net irrigation minus the crop water requirement. So those are the three most important formulas that we'll be using. The second question, we'll be checking it in the next video. We'll be looking at the zones. How can we categorize this leaching in terms of zones? Maybe the zones like the root zones, that is maybe the upper part of the root zone of the crop, the middle, and the lower part. We will be checking how we can classify that and be more efficient in our calculation of the leaching water requirement. Thank you, and see you in the next video so we can look at the next example. Thank you.